This is Rough Science, coming to you from the Spice Island of Zanzibar off the east coast of Africa. Our scientists face their toughest trial yet as they take on the ocean. They have to complete a set of marine challenges with a few simple tools, some basic bits of kit, and a boatload of ingenuity. Our base on the Indian Ocean is a traditional fishing dhow, and our site on land is an isolated beachside workshop. It's destination paradise for rough science. Our four scientists are Kathy Sykes, a resourceful physicist with boundless energy. Mike Bullivant, an imaginative chemist who embraces the near impossible.
Oh, my word!
Ellen Macaulay, a fearless have-a-go botanist from Missouri.
Next thing is rinse it.
Jonathan Hare, physicist, inspired inventor and artistic engineer. And me, Kate Humble, an experienced diver. I'll be going underwater to put their inventions to the ultimate test. Together we are Rough Science.
Zanzibar, as you know, is surrounded by a lot of smaller islands, which in turn are surrounded by absolutely treacherous reefs. So to help ships navigate this terrifying underwater obstacle course, there are lighthouses. But there isn't one over there to the west on Bowie Island, which is this one here. And this area is really the busiest shipping area around the island. So I thought it'd be rather nice to give Bowie a little present. You are going to build Bowie a lighthouse. OK?
Yeah.
Ellen, I think you can come up with a light for it.
Okay.
As bright as the sun. And then, Mike, I want you to make it even brighter. Jonathan, lighthouses flash.
Right.
So if you can come up with a mechanism that will allow this incredibly bright light to flash,
Okay.
that would be good. And Kathy, come up with a way to power that mechanism so it keeps going. Keep it flashing. You've got 3 days. The workshop up there, everything in there, anything around here, and of course, there's the trunk.
Okay.
And what is that?
So the team have got less than 72 hours to build a working lighthouse on an uninhabited island. There's no electricity supply on Bowie, and it's a pretty inhospitable place. On the evening of day 3, I'll be sailing past in our dhow, and the lighthouse must warn me off the rocks. Kathy heads to Bowie Island to find the best spot on the coast to site the lighthouse.
Well, this is the side of the island that's along the shipping lane. But there's just nowhere to land. It's all cliff. So I think we're going to have to go around to the other side and hope we can find a place to land there.
On the sheltered western side of the island, there's a small jetty where the boat can dock.
OK, so see you in a couple of hours.
But Kathy has to trek a couple of kilometres through tropical undergrowth to reach the strip of coast nearest the shipping lane. Back at base, Jonathan is figuring out how to make a light flash.
I think my part of the challenge is to take Ellen's light that she's going to make and somehow chop it. The reason for doing that, of course, is if you're in a boat and you're going past an island, you know, it could be light from a window or something. So you want to know that it's light from a lighthouse. So I want some mechanism which is going to be very easy to move. So if I can drill a hole through these, maybe I'd be able to use them as ball bearings.
Ellen's off to a local coconut plantation in search of a fuel supply for the light which will be at the heart of the lighthouse. Over 500,000 coconut trees grow on Zanzibar and the surrounding islands. Ellen will stop at nothing to harvest as many of them as she can.
OK.
OK, good enough. Thank you.
So what are you going to do with all of these?
I'm going to make oil.
Really?
Yeah. So I have to husk them all, then chop into the nut, grate them, boil them, filter them. This is going to be a lot of work.
It is going to be a lot of work. And, I mean, you know, I know about coconut oil. I mean, it's in a lot of skin products, hair products, but does it burn?
I hope so.
Well, you don't know.
No, but oil typically burns. And this is a nice, clear, pure oil, and it should burn.
Well, I admire her spirit. She's got a busy day ahead of her. Mike's retreated to his rough science chemistry lab to think about exactly how to get the light to burn brighter.
Well, what I've got to do is produce oxygen to brighten Ellen's flames. Now, there's rather a neat way of doing that, using electricity to split water into hydrogen and oxygen. When I connect the battery up, you'll see that not very much happens because water isn't that good a conductor of electricity. But if I add some battery acid to the water, it improves the conductivity of it no end. And look what happens at the electrodes. The gases come streaming off. The gas that we need is the oxygen to brighten Ellen's flames. The hydrogen we have no use for. There's twice as much hydrogen coming off as there's oxygen coming off at this electrode, and that fits in with the chemical formula for water, H2O. Twice as 2 hydrogens, 1 oxygen.
It all sounds rather ambitious to me. It's halfway through day 1 and Kathy's tramping across Bowie Island. Jonathan's starting to build a DIY lighthouse. Mike's scaling up his oxygen production. And Ellen's wrestling with coconuts.
There we go. I've seen this done before, but I'd never actually done it, and I didn't realize how hard it was. A little bit of coconut biology. The whole thing is the fruit, the husk is on the outside, the nut is on the inside, and the meat is inside the nut. And that is what we get the oil from. There we go. We've gotten almost all the husking done. It's nearly killed me. And now, we just have to grate these.
Rather you than me, there's a mountain of them, and it's only the first stage of the process. Jonathan's racing ahead. His idea of making the light flash with the help of a few golf balls is starting to take shape.
Look, it's going round and round.
Yeah. And this is basically the top of the lighthouse.
OK.
So on this base, which is going to be secure,
Yeah.
you're going to have Ellen's lights. And then on this disc here, we're going to have slats, which will be able to chop the light.
Yeah.
Now, all those slats and everything are going to be quite heavy.
Yeah.
And somehow, Kathy's got to power this. So what I've done is I've put it on these sort of bearings I made out of the golf balls.
It looks lovely. Can I just have a little spin?
A very frictionless system, so it's easy to turn. The problem is that it rolls off at the moment, and I sort of knew that was going to happen. So I'm going to play around with putting some struts here to stop it moving off. So I need to experiment a bit.
So you've got a bit of tinkering time, but yeah.
Look.
On Bowie, Kathy's finally made it to the coast facing the shipping lane.
We're just at the top of Bowie Island. So if we put the lighthouse here, any ship that's coming from the north is going to be able to see us. There is a damn great reef out there that I can see on the map and can actually see. So there'll be a really good point in putting the lighthouse just here.
At the workshop, Mike's got 2 funnels ready to start Operation Oxygen.
The demonstration I did was on a small scale in a little jam jar, but we're going to have to scale it up to produce enough oxygen for the lighthouse. So this is 10 times scaled up. You can see instead of 2 electrodes, we've got 20. The container's a lot bigger, and instead of the little tiny battery, I'm going to use a car battery, maybe even 2 car batteries. Well, let's go. That's positive and negative. Let's see what happens. As we generate oxygen, it'll push the air along and we'll see bubbles coming out of here. And that'll give us an indication of the rate at which we're forming oxygen. This is the one we want, the oxygen, which forms this red electrode. I'm just making sure that these seals are airtight, because we don't want the oxygen to leak out.
The idea is that oxygen goes up the tube and collects in the jam jar.
I'm confident when all the elements come together we might get a brighter flame.
It's late afternoon and Ellen's been husking and grating her coconuts for 6 hours. To extract the precious oil, she's washing the shredded flesh and is boiling up the liquid. Jonathan sorted the revolving structure. He's even found time to come up with an inspired addition to the design.
To make it look like a lighthouse, we want to make it flash. But what would be even better would be to make it send a signal. So we arranged a little mechanism here, which you're going to be able to send a Morse code signal, maybe a B. So you know that this is the lighthouse from Barry Island. This would be where the boat is up there, hopefully. The light's going to be here, Ellen's lights are going to be here, roaring away, sending light through. So they send a dot through there, then there'd be a space, another dot there, space, dot there, and then a period where it's off. B in Morse code. God knows how we're going to drive this. Anyway, that's another problem.
Kathy can't begin to think about how the lighthouse might turn until she gets back from Bowie Island at nightfall. It's the end of day 1, and Mike's yet to collect any of the oxygen he's producing. And Ellen's got many pots to boil before she has oil to burn. With only 48 hours left, they're a long way from making a lighthouse that'll shine out across the shipping lane. Day 2, time for Kathy to report back on her recce of Bowie.
The island isn't very hospitable. It's just this kind of big, flat band of coral, kind of upstanding from the ocean, with really steep, undercut cliffs. And there's only really one sensible place to access the island by boat.
Right.
Unfortunately, it's on the far side of the island, nowhere near the shipping lane. And there's only really one path. So if we take that path and go as far as we possibly can, we end up at the kind of most northerly point of the island, and I think we have to put the lighthouse there.
So is the path wide enough to take all the equipment?
We can, but it's pretty narrow and difficult.
OK, so that's going to have implications for everybody, isn't it, as to how haulable and fragile your stuff is.
So not only have they got to make a working lighthouse, but it must be one that can be shipped and carried 2 kilometres across the island. Ellen's straight back to the fire. Her coconut liquid has settled overnight. She's skimmed off the top layer and has been boiling it since dawn.
Now what happens after you fry it for about an hour? You end up with pure coconut oil on the top and fried coconut residue, which we will squeeze out. We've got our oil for lamps.
All the effort has paid off, but will the oil burn brightly enough to be seen out on the ocean? Now the real work begins for Kathy. Jonathan's revolving structure won't make the light flash unless Kathy can make it turn.
This is an amazing device, Jonathan.
Yeah, well, it's not too hard to move, is it?
It's reasonable. So, what are our options?
Well, yeah, I mean, we could have some mechanism, I suppose, like a big weight falling, and as it falls, it unwinds.
Well, I quite like that. That's what I was thinking, because we've got this cliff, about 3 metres high, then that's quite a nice distance to have something falling.
Kathy's solution is to use the energy from falling weights to make the lighthouse spin round at the right speed. Now, will that coconut oil burn?
The problem is, coconut oil, unlike petrol, if you light a match and stick it in it, petrol goes up, coconut oil won't burn immediately.
OK.
What you have to do is introduce a wick. By capillary action, the coconut oil is drawn up the wick. We light the wick, but as soon as it starts to burn, it evaporates a little bit of coconut oil. And it's the coconut oil that's evaporating that actually burns. And that's why one wick will last all night. You're not burning the wick, you're burning the evaporated coconut oil. And so now we've got a lamp.
Perfect.
She's done it. All we need now are Mike's oxygen jets to really make the light as bright as it can be.
How are you getting on, Mikey B? I've just seen you sort of wandering around with funnels and bits of wire all day.
I'm a happy bunny, but we've got a problem.
OK.
We're generating oxygen in this scaled-up version of my oxygen generator, scaled up from the jam jar experiment. And the oxygen is supposed to feed through here, up into the jam jar, and we see bubbles coming out of here, but as you can see...
There are no bubbles. So does that mean that basically it isn't generating oxygen?
It is generating oxygen, we're just losing it. You can see the bubbles?
So all those bubbles
That's
around the top, that's your oxygen, and of
We're
course you
losing
can't collect it.
So what I've got to do is pack that with sealant, make sure it's completely sealed, so all the oxygen goes up the funnel, along the tube, and then tomorrow, I hope, you'll see bubbles come out of there.
So do I, because we're counting on you. You know, you said Ellen's going to give us a bright light.
And I'll make it brighter.
Exactly.
We'll do it.
Mike won't succeed unless he can trap the escaping oxygen. Meanwhile, Kathy's experimenting with different-sized rocks. She wants to find the correct weight to turn the lighthouse at the right speed.
This looks desperately simple, Kate.
Yes.
Highly technical stuff. I've taken as thin a bit of metal as I really can.
Yeah.
And I've wrapped this very strong string around it hundreds of times.
I hope it is very strong, because that's a very big rock.
I hope it's very strong as well, Kate. And then attached it to the big rock. As the rock will gradually go down, I hope, because I don't want it to rush down quickly. As it gradually goes down, it will rotate this, which will rotate this. And that means if we have a rope in here, we get a big movement of rope for each little movement there, and that will drive the whole of the lighthouse.
So what you're doing is effectively converting the energy of that stone falling into a useful force that can drive the lighthouse.
That's it. Yeah. Should we give it a go?
Yeah. Leave me to...
If you hold on to that.
Hold on to this, OK.
And I will lower this and hope that nothing breaks.
Careful, careful, careful.
Oh! Well, the string ain't that strong.
Right.
There's only a couple of hours left in the day. Jonathan's moved on to building a frame for Kathy's powering device. Mike's plugging his leaks.
It's like icing a cake.
And Ellen's making the most of her coconuts.
I'm using the coconut fiber that I got from on top of the coconut tree to twist and make the wicks. And I think I'm going to make 16, like a birthday cake. So, can we see it from far away? That I don't know. That's going to be the tricky bit.
That flame could do with some help from Mike's oxygen, if he gets any. And what about Kathy's rock and rope system?
I'm now using a stronger rope, so I'm hoping not to drop my rocks into the sea.
It's great. Lovely. Look at that. It spins beautifully. That's looking great, Kathy. Well done.
The rope is attached to its own spinning system, and Jonathan's frame will connect it to the lighthouse. That's the idea, anyway, but it hasn't been tested yet, and it's nearly the end of day 2. Tomorrow, the team have to finish the build, ship it to Bowie, and get it working by nightfall. That only leaves them the morning to complete the lighthouse. Day 3, and everyone is up against it. But as Ellen puts the finishing touches to her biscuit tin lantern, she hits an unexpected setback.
Kathy, I'm worried about one thing, and that's how we're going to light these, because I'm really... they aren't lighting because of all the wind.
I hadn't even thought that this might be a difficult stage.
I'm going to have to put it completely in a windbreak.
Yeah.
Come on, baby. Come on.
And if it's gusty in the workshop, I don't fancy its chances on an exposed cliff edge on Bowie. At least Mike is ready with his oxygen. Or is he?
This is the oxygen line. Let's put this in here. see if we get the bubbles of oxygen. You have to give it them. See, this is good. This is good. This is oxygen. And I think I'm going to go and get Kate and prove it to her that this is oxygen.
Well, it looks like you fixed the leak.
Yep. I've been collecting the oxygen in this test tube.
Right.
And there's a standard test for oxygen. If you could light that splint there and get a good glowing ember.
It's quite windy. I might try and do it. OK, so what's going to happen? What do I need to do next?
When you introduce that lighted splint into there, it should reignite. If
so
this is
it will
oxygen
flame.
in here. You ready?
Yep.
Should be right up.
It's gone out, Mike. What's going on, Mike?
I know that we're producing oxygen. We're generating oxygen. I just can't prove the fact.
Mike's run out of time to make any more tweaks and changes to his collecting system. He's going to have to abandon Operation Oxygen and join forces with Ellen on windshield duty. The Dow's crew are standing by to go to Bowie Island.
You're not going to take this over there, are you?
No.
And Kathy and Jonathan are under pressure. Will the rocks make their lighthouse spin?
It's going to work.
Do you think so?
Yeah, we need a bit more weight on it. It's so near.
That's pretty close.
Yeah, so
It is pretty close.
Stick another weight on it, Kathy, go on.
Whoops.
That's still not... That's still not going.
It's not that. Need more weight.
The rocks aren't heavy enough to drive the lighthouse, but Kathy's determined to prove that her mechanism can work before we leave for the island. She's using buckets of water to add weight.
Going in. 2. Going on.
This is the last test. If it goes, it doesn't matter.
Yeah, it's the last, it is the last test.
Should we see if it goes? Okay, let it go.
It's going.
It's going.
It's going. Look at that. Is it going?
It's pretty close. John, the rope.
Oh, it's tantalisingly close. The team decide the best thing to do is to get the lighthouse to Bowie and continue working on it there.
Hey, well, this is the point that we're going to put the lighthouse.
OK.
So what do we do? So we go down to the jetty, which is the other end of the island, carry everything back up here.
We dock at Bowie. Now there's the trek through the undergrowth to get to the point overlooking the shipping lane. All the component parts of the lighthouse have to be carried. Eventually, we get to the right spot, but there's only 2 hours left of daylight to build the lighthouse.
OK, folks, haven't got much time, have we?
You're right, let's do it.
Where do you think, Kathy?
Well, do you think we could put it here?
Yeah, and we can use the ropes that go back to the mangroves.
Would you be happy to tie the other end of this to a tree?
First, we have to secure the lighthouse to the edge of the cliff.
We want to do another one, going from here off to another tree.
Voila.
Hey, guys, is it good enough to go with?
Hold on, just 1 second. I want to secure it.
Mike B? Kate and Mike, hold the thing back and grab the thing if the rope comes off. I'm going to put 2 more rocks in.
This time, Kathy thinks she's got the right weight, but the connecting rope must stay on the wheels if the lighthouse is to turn.
That's a hell of a weight on that thing.
OK. Right, let go of this wheel. OK, it's going.
It's going.
It's going.
Yeah.
Go on.
Is it?
It's really, really close. Can we put a little bit more water in?
There's no room for it. We've got half a ton of rocks in there.
It really is almost just going. You can see it's just a little feather more weight, just a little feather.
Oh, hold on, it's stuck on a rock.
Let go, Kathy.
It's going. The rock's catching, but it is actually going. Look!
Oh, yes, yes.
Yes!
Oh.
It's gone. Keep away from that wheel. Look at no.
Hey, but it was going.
It was.
It was actually going. Hey, well, look, if we keep fiddling around with it...
Do you think?
I think.
Ever optimistic Kathy. Ellen puts her lantern in the centre of the lighthouse and lights all 16 wicks. Ellen, Mike and I head back to the dhow. We want to see the lighthouse flash from the middle of the shipping lane.
What are we going to do now?
Jonathan and Kathy don't have long to get it turning. Kathy adds another rock. But it just won't work. Time for a bit of rough science ingenuity. If an electric screwdriver can turn a screw, can it turn a lighthouse?
This is great.
We're out beyond the reef. If we can see the flashing light from here, then the lighthouse is doing its job.
Any sign of it yet?
Nope.
Can't see anything.
I think it's just around the corner there.
Let's just make it do one rotation, make sure it doesn't stop.
There you go, look! Short! Short! Short!
That's a bee!
Bang the gong, bang the gong.
Yes!
The rocks! Go away!
Well, I think we could say that the light worked. And we have a rough science lighthouse. That's all for this week, but join us for more rough science.
Next week, we set out to protect one of the most spectacular reefs in the Indian Ocean. For a free magazine about all Open University programmes, call 0870 900 9581 or go to open2.net, where you'll also find more about this week's challenges.
Hyrax var, meaning go Hyrax.
I've never sold anything to anyone in a retail environment.
You look like a bird who's swallowed a